The goal of this video is to make you a master of differentiating with the fundamental theorem of calculus. So here we have 5 different integrals, functions represented as integrals, and we want to find their derivatives. And I'm going to make it very easy for you to understand deeply how the process works, which is important, and then number 2, to really do it rapidly. At the end of this video, I'll show you some shortcuts once we've grasped everything. So let's dive into it and start off with the first one, which is y equals to the integral from 1 to x of sine of t squared dt. We want to find what is the derivative of y with respect to x. Now I'll emphasize these points as we go along, but it's very important that y is a function of x, not a function of t. Okay, understanding that will help avoid making silly errors. Okay, so y is a function of x. How do we actually understand this function? Now we cannot actually find the antiderivative of sine of t squared in an easy to write down form. It's not possible, but we can differentiate it. Okay, so that's what we're going to do. There are cases of problems where you can actually evaluate the integral and write it explicitly, but even then you don't want to do that. You want to follow the process we're going to do right now. So what is the process? Well, assume we could find the antiderivative of sine of t squared. Okay, let's assume so. Okay, so let's say that antiderivative is f of t. So what that means is that if f of t is an antiderivative of sine of t squared, it means that f prime of t, the derivative of f of t, is just sine of t squared, right? Now once we found such a function f of t, whatever it is, okay, we don't even have to know what it is for differentiating y. We can express y in terms of f of t. How do we do that? Well, what we do is we just plug in the upper limit and subtract off plugging in the lower limit, right? We find the antiderivative of sine of t squared, which is f of t, that's what we're calling it. And then our actual integral, which I'm going to call I of x, okay, I for integral. I of x is just going to be equal to f of x minus f of 1. That's what I of x is going to be. F of x minus f of 1. Just plug in the upper limit, subtract off, plug in the lower limit, right? So now to differentiate I of x, which is dy dx, right? For y equals this function, to differentiate that, all you have to do is say, okay, I prime of x is going to equal to f prime of x minus, so the derivative of f at x, minus the derivative of f of 1. But f of 1 is a constant with respect to x, okay? So it's a constant in general. So therefore, it's just going to be minus 0, and that's just going to be, well, f prime of x, here's the important thing, f prime of t is sine of t squared, so f prime of x is going to equal to sine of x squared. This is super important. You don't want to say sine of t squared, okay? So sometimes students make this error. It's quite common. You know, I've taught these concepts at Princeton University in classes, and it's a very common mistake for students to assume that the derivative should be sine of t squared. Remember, our original function is as a function of x, okay? And so our derivative should also be a function of x. We don't have to do anything with the t at the final answer, okay? The integrand, the variable you're integrating with respect to, is not appearing in the final answer. And another important point you'll see, which is very important to remember, is you never have to differentiate the inside. Okay, unless you're taking the second derivative, you get to this answer, you want to take the second derivative, you don't want to differentiate the inside, okay? You don't have to do that, okay? So the final answer is just sine of x squared, and that follows from the fundamental theorem of calculus, okay? That's our process for integration. Now the next one we're going to do is going to be number 2. Let's dive into it. I'm going to erase this side of the board. All right, so our next integral that we have now is the integral of 1 to square root of x of cosine of t squared dt. We want to differentiate y again as a function of x. And now things are starting to get spicy because we've got a square root of x in the limit, and we need to figure out how to deal with that. But sticking to our processes is going to make everything clear. Again, we cannot find the antiderivative of cosine t squared explicitly, but it doesn't matter, even if we could. We're going to call it something. So we're going to assume that let f of t be the antiderivative of cosine of t squared, so that in this case what that means is just the derivative of f of t is cosine of t squared. Okay, we don't know anything about f, we don't have to, except that its derivative is cosine t squared. And now to find the original integral, which we call I of x again, it's a function of x, we just have to plug in the upper limit into f and subtract off the lower limit plugged into f. So again, we're going to get I of x is going to be f of the square root of x minus f of 1. Okay, that's our process for integrating. We just find the antiderivative, we plug in the upper limit, subtract off, plugging in the lower limit. That's when we want to calculate an integral. Here we don't want to. We want to find a derivative, so we actually don't need to know what the antiderivative is. So now we've got this. How are we going to differentiate it? This is going to become very important. To differentiate the integral here, I prime of x, we're going to have to apply the chain rule. Okay, so the chain rule is very crucial here. We're going to have to first differentiate the outside, Okay, so that's going to be f prime of the square root of x. And then multiply with the derivative of the inside, which is square root of x, its derivative is 1 over 2 root x. Okay, so that's like x power half. Square root x is x power half, so it's half times x power negative half, and that's what this expression is. And again, the derivative of f of 1 is 0 because it is a constant with respect to x. Okay, so this is just going to be minus 0. And now we're almost done. We have to be very careful again. F prime of square root of x, what's that going to be? Well, f prime of t is cosine t squared. So again, we want to plug in the square root of x as t here. Okay, in this formula, so we're going to get cosine of the square root of x squared. So I'm going to do that in 2 steps. So it's going to be cosine of the square root of x squared times 1 over 2 root x. And of course, cosine of the square root of x squared, the square root of x squared is just x. So we're going to get cosine of x divided by 2 root x. And that's going to be our derivative. And again, it's important to check we should not have a t in our final answer. That's our answer, and it's sort of engineered, I engineered the cosine t squared and the square root x, so it kind of nicely cancels out. A quick word of remark is that the square root of x squared is x, but the square root of x squared, this x squared, you then take the square root of that, that's the absolute value of x, okay? Important point that sometimes people don't know. So that's important to keep in mind. Let's now get into the third integral, and this is going to get into one more level of complexity. So you're going to have to be super careful. All right, so here we have the third integral. And by the way, if you're enjoying my content, please don't forget to hit that like button and subscribe to the channel. I do everything in math on my channel. I'm a professional mathematician, and I'm delivering elite math education to you in a way that doesn't exist on the internet in the current form. So if you're really loving my content, please don't forget to do that. And let's just get into the integral now. So we've got into this integral, and now we do the same process again. Okay, it's always the same process. We don't need to know how to find the antiderivative of 1 over the log of t. Okay, we just call it something. Okay, so we call it f of t, and we know that f of t has the property that f prime of t is equal to 1 over the log of t. The derivative of f of t is 1 over the log of t. And notice just before we get further that this integral is the integral of x to sine x of 1 over log t dt. Now there are 2 functions of x, one in the upper limit and one in the lower limit. Okay, so we're going to have to be careful here. That hasn't actually occurred so far in the problems we've worked out. So what we want to do is we want to call our function again I of x. What is our definite integral going to be? As always, we find the antiderivative of 1 over log t. Whatever it is, we call it f of t. And then what we do is we plug in the upper limit into f of t and subtract off plugging in the lower limit into f of t. So again, we're going to get f of sine x minus f of x. Okay, that's going to be our answer, f of sine x minus f of x for the integral. And as always, we only care about the derivative, so we don't need to know f because we know the derivative of f. So again, we know that the derivative of I prime of x, this is going to be, we have to apply the chain rule again. Okay, the same idea as before, differentiating a composition f of sine x. It's going to be the derivative of f at sine x times the derivative of the inside, the derivative of sine x, which is cosine x. And then we're going to subtract off the derivative of f of x, and this time this is not a constant. So its derivative is not going to be 0. Its derivative is just going to be the derivative of f of x. It's going to be f prime of x. Now we're almost there. Now we have to be careful again. We want to plug in sine x into our formula for the derivative and x into our formula for the derivative. So we know that f prime of t is 1 over log t, and so that means that again f prime of sine x is just going to equal to 1 over log of sine x. So we're going to get cosine x divided by log of sine x, and then we're going to subtract off f prime of x, which is 1 over log of x. Okay, and again, you want to be very careful. If you're doing this in homework, so exams in university or school even, you want to be super careful about making sure your final answer does not involve a t, okay? Our function is a function of x, our t is inside the integral. So when you do this integral, you're going to get something dependent on x, not dependent on t. Okay, it's like whenever you do a definite integral, if it's dx, your final answer, if your limits are just constants, your final answer is just in terms of those constants. It doesn't really depend on x, right? So same principle there. So I hope that this is so far very clear. I'm trying to really drain this in very, very clearly so that you're super confident with doing these problems. And what I'm going to do at the end is I'm going to show you a fast way. Rather than going through this process each time, I'm going to show you a fast lightning way to do all of these problems in one. Super fun trick, but I first want to teach you the concept so that, really we master that together very clearly. So let's get into the fourth integral now. All right, so now we have the fourth integral, and this is a bit interesting because for the first time our variable is in the lower limit and our constant is in the upper limit. Unlike in problems 1 and 2 where our variable was in the upper limit and our constant was in the lower limit. Now I'm going to show you two ways of understanding this. The first is we're just going to stick to our processes, okay? Just to kind of be very clear, stick to the same processes as we've always done. We don't necessarily need to know, we don't need to know the antiderivative of e to the cosine t. We just say let f of t be the antiderivative so that f prime of t is going to equal to e to the cosine t. Okay, that's the antiderivative of e to the cosine t, whatever it is. We don't need to know anything except its derivative is what is inside the integral. And again, we have to plug in, we know the integral is I of x. So again, we plug in the upper limit and the lower limit into our antiderivative f and we subtract them. Okay, so f is our antiderivative, whatever it is, and then our integral is going to be f of 5 minus f of x cubed. That's going to be our answer for our integral. But again, we don't know f, but we only care about the derivative of the integral and therefore only the derivative of f, which we do know. So here we can say that I prime of x is going to be, well, f of 5 is a constant, it doesn't matter, its derivative is 0, and then we have a minus f of x cubed. What is the derivative of minus f of x cubed? Don't forget the negative sign, okay? This is going to be the key difference. The negative sign exists, so we're going to have to differentiate f and plug in x cubed, differentiate the outside, and then multiply with the derivative of the inside, which is derivative of x cubed is 3x squared. So we're going to multiply by 3x squared, and then that's going to end up being, well, derivative of f at x cubed, we can plug in into our formula. Our f had the special property, its derivative was e to the cosine t. So plug that in, we get minus e to the cosine of x cubed. Okay, again, you don't want to say t cubed. I've seen this mistake a lot. It's easy to make sometimes when you're doing a lot of problems, so you just want to be careful. So you get this times 3x squared. You could also write the answer as minus 3x squared e to the cosine x cubed. Okay, I've just left it in this form, but that's all fine. Now I want to make one remark, which is a quick trick. It doesn't really matter since we follow the same process anyway. But if you want to interchange the upper and lower limits, you can use this formula. This is going to be minus the integral from 5 to x cubed of e to the cosine t dt. Okay, so if you want to flip the upper and lower limits, you can just put in a negative sign. And if you think about it, you would get the negative of the answer you would get if you just had integral 5 to x cubed of e to the cosine t. You differentiated that, I encourage you to do that just as practicing while watching the video. You would get this answer without the negative sign. Okay, so you can do that trick, and that's basically, it's an integral law, it's pretty important. And so there we have it. So the fourth integral has been done, and the fifth one is going to be the last one, and it's just going to reinforce everything. So let's dive into the fifth one, and then I'm going to show you the fast tricks for finding these integrals. All right, so we have the last function here. We want to differentiate with respect to x, and I encourage you to actually try it out yourself before you watch me do it, and then we can go through it together, and then I can show you the fast ways without doing this process. We're just doing them all at once. Okay, so I'll show you this really beautiful trick. But let's now get into it, assuming you paused it and try to do it yourself. It really helps us practice. So let's get into this. So what we're going to do here is we're just going to do the same process again. We call the antiderivative f of t. Okay, it doesn't matter what it is. And as you do more of these, you can mechanically sort of skip the steps. But I'm sort of doing it every step clearly so that you can really see what's going on and understand it. Because a lot of people, they've learned this mechanically, don't understand it. And then when the limits change or there's something different in the problem, they're lost. Okay, so by understanding it, it helps a lot. So f of t, we're just going to choose the antiderivative. F prime of t is going to be the root of the tangent of t. Okay, we don't know anything about f except its derivative, and that's all we need to know. Now we can find out the integral. So I of x is the integral. This is going to equal to f of x squared minus f of x cubed. Okay, so again, the antiderivative is f. How do you find the integral? You find the antiderivative of the integrand, and then you plug in x squared, plug in x cubed, subtract the two in the right order, which is f of x squared minus f of x cubed, upper limit minus lower limit. And now we can find the derivative. So I prime of x is going to equal to, we're going to have to do two chain rules now. Okay, so this is the first problem where we had that, two chain rules. So first we get f prime of x squared times the derivative of x squared, which is 2x. Okay, and then we're going to subtract off the derivative of f of x cubed, which again by the chain rule is f prime of x cubed times the derivative of x cubed, which is 3x squared. Okay, and now what we have to do is just plug in. You know, we know f prime of t is the square root of tan t. Now what is f prime of x squared and f prime of x cubed? So f prime of x squared is going to be the square root of the tangent of x squared times 2x, and then f prime of x cubed is going to be the square root of the tangent of x cubed times 3x squared. Okay, so that's going to be our answer, and if you like, you know, I didn't do this last time, but just to show you, if you like, you can just write it out in one go. 2x times the square root of the tangent of x squared minus 3x squared times square root of the tangent of x cubed. And your final answer should never involve a t, okay? I keep emphasizing this, should be in terms of x, and you never have to differentiate the square root of tan t, okay? You should never do that. Sometimes it's easy in exam stress, you know, to mess that up. That can happen to anyone. So that's why it's important to do a lot of problems so you really master the tricks, okay? And so now we've done all 5. What's the fast method? I've kind of shown you this process where we have to call the antiderivative something, we have to go through all these steps. How do we just bypass all the steps and just do it by inspection? I'm going to show you this, but it's a powerful thing, and I want you to promise that you're not going to use it until you fully understand this step-by-step process. So when you know you can do this step-by-step process and justify it, that's the point. When you practice a lot like that, then you can do this fast trick, and I'm going to show it to you right now. Alright, so now I'm going to show you the fast way, bypassing all the steps, and this is going to be super fun and easy. So I've got a new marker, so everything's going to be super clear. So what we want to do is find dy dx for each of these functions. So remember, the key principle is that the derivative of the integral gives back the function. Okay, so when you're differentiating this integral, what you want to do is, this is the shortcut trick. Okay, you want to do is you want to take sine of x squared, so plug in the upper limit into the integrand, sine of x squared, and then subtract off sine of 1 squared. Okay, so plug in the lower limit. Now that's not quite right, right? Sine of 1 squared didn't appear in our answer. We have to remember to multiply by the derivatives of the upper and lower limits in each case. So I'm just going to put that in here. The derivative of x with respect to x, and here it's going to be the derivative of 1 with respect to x. And now, because of this, we see that there is a cancellation, so this is going to be equal to 0. It's differentiating a constant, so this whole thing disappears, and our final answer is just going to equal to sine of x squared. Okay, so that's number 1. Pretty cool. Okay, so this is going to help us to do the other ones fast too. So number 2 is, and I'm just going to erase this for number 2. Number 2 is the same idea. Basically, we're differentiating this integral, so we should get back what's inside the integral, because differentiation and integration are opposite. So here we should just get, when you take the derivative, we should get cosine of, plug in the upper limit into the integrand, so we're going to get root of x squared, and then we're going to subtract cosine of 1 squared, so we're going to plug in the lower limit into the integrand, and in each case we have to multiply with the derivative of what the limit was. So in the first case we have to multiply with the derivative of the square root of x, so it's going to be the derivative of the square root of x times dx, and here we're going to multiply with the derivative of 1 times dx with respect to x. And of course, in that situation, this is going to again be 0 because you're differentiating a constant. So our final answer is just going to equal to cosine of x times the derivative of root x with respect to x, which is 1 over 2 root x. Okay, so I hope you can kind of see the parallel. We're doing the steps I already showed you, but in a shortcut way. I'm giving you a gimmick for doing this without actually saying that f of t be the antiderivative of cosine t squared and f prime of t being this. We're doing the same process but in a gimmicky way. So I'm now going to get into the third one, and I'm going to do this faster now. Alright, so number 3. So we're going to do number 3. And in this case, it's the same principle. I'm going to do it faster. Plug in sine x into the integrand, so you get 1 over the log of sine of x, and then plug in x into the integrand, so subtract that off, minus 1 over the log of x. And in each case, we want to multiply by the derivative of the limit. So here the limit was sine x, the upper limit was sine x, the derivative of sine x is cosine x, and here the derivative of x was 1, so we just multiply with 1. So here we're just going to get cosine x by log sine x minus 1 over log x. Okay, that's it. Okay, that's number 3. And then number 4, and you can see this is getting quick now. Number 4, same principle, plug in the upper limit into the integrand, so you're going to get e power cosine of 5. Plug in the lower limit into the integrand, so you're going to get e power cosine of x cubed. And we don't want to forget to multiply with the derivatives of the limit. So the derivative of 5 with respect to x is 0, so that's going to be multiplied by 0. And on this one, the derivative of x cubed with respect to x is 3x squared. So this is going to get multiplied with 3x squared. Okay, so again, you see, like, I'm just doing this quickly, and this is something you can do once you understand what we're doing. And I want you to make sure that you really can see that this process matches what we did earlier in the video. All right, so for number 5, it's the same idea. We're differentiating the integral, so plug in the upper limit into the integrand, so you're going to get square root of tan of x squared, and then plug in the lower limit into the integrand, so we're going to get square root of tan of x cubed, and then in each case you have to multiply with the derivative of the limit. So derivative of the upper limit of x squared is just 2x, derivative of the lower limit x cubed is 3x squared, so that's going to be our answer. So very quick, and I hope you loved that video. And if you want to see a lot more fun math videos, please check out my channel. I've got a whole playlist of integration. Here it is. Integration, all kinds of integration tricks. It's super fun and comprehensive. It's growing by the day. So check it out over there. If you want another fun video, it's the most popular video on my channel right now. It's why the integral of 1 over x. You know, a lot of people, they think that the integral of 1 over x dx is equal to log absolute value x plus a constant. Actually, this is wrong. And if you want to know why, it's a famous misconception in calculus. You can check it out here. See you in that video. Have an amazing day, and I'll catch you later. Don't forget to hit that like button and comment down below, and I'd love to hear from you.